In this video, I'll be discussing with you about the gauges in railway track. Now, basically, you need to understand the definition of it first. So, the gauge of a railway track is defined as the clear distance between the inner faces of the two rails, if we are talking about a track gauge. On the other hand, I told you that there is something called as wheel gauge also, which is the clear distance between the inner faces of the pairs of the wheel or inner faces of the flanges of the wheel, which is attached by a single axle. So these are the two definitions that you need to be clear about. There are different gauges which are being used worldwide. So in the olden days, the Britishers used the flanges which were placed on the outer side, right? So it would look somewhat like this. So this flange, which is now on the inner side, was actually on the outer side. Okay, and then the coning also was done on the reverse direction. It's like you are shifting this wheel here and this wheel here, right? It was like that. So in the olden days, the Britishers used flange on the outer side of the wheels. Okay, and the gauge at that time was considered between the outer faces of the wheels or the flanges. So the distance which was then is around 1.5 to 4 meters. Later, because of its inefficiency that were observed in the olden days, the flanges were shifted in the inner side instead of changing the entire rail system, which was not possible to be changed. So the easiest way to adopt with the existing condition was to just shift the wheels in the other way. Okay. So the present gauge, what we have now, is actually equal to the past gauge, that is 1.524 meters minus 2 times the rail width at top, that is 0.0445 meters. So it comes to around 1.435 meter. So 1.435 meter was the common standard gauge that was used in most of the countries wherever the Britishers had ruled in those days. So rather than changing the whole rail system running for thousands of kilometers, it was considered that it would be economical to shift the wheels rather than changing the whole rail system. So that's how the standard gauge in most of the countries was found to be as 1 point, or still in most of the countries it is 1.435 meters. That is the standard gauge, right? The Indian gauge was actually adopted by the East India Company during the British rule, and it was considered as 1.676 meters as the standard gauge. And India still retains the same gauge system, and that is what we have as the Indian standard gauge system, and that is again named as a broad gauge, right? So standard gauge, that is broad gauge, is 1.676 meters. Meter gauge mg, that is 1 meter. Narrow gauge is 0.762 meters, and then the feeder gauge or the light gauge is 0.610 meter. So these are the things that you are expected to remember. It is very important, okay, because we'll be using these for calculations in geometric design, right? Now, when you know what a gauge is, what are the different type of gauges worldwide, and what do we have here in our own country, right? It would be time for you to understand how to select which gauge under what circumstances. Okay, whether you want to adopt meter gauge or narrow gauge or feeder gauge or light gauge or even standard gauge, that is broad gauge, on what basis do you think you will be selecting this? It depends on certain factors. So there are 5 broad factors which are being listed. One is cost of construction, second is volume of traffic, third is development of areas, and then the fourth one is physical features of the country or region, and then the fifth one is the speed of movement. So when we talk about cost of construction, uh, there will be obviously an increase in the initial cost if you are trying to have a wider gauge, because if you have a wider gauge, the cost of earthwork will increase, the cost of rail also will increase, the ballast quantity also will increase, the number of sleepers required also will increase, the dimension of the sleeper also will be increased proportionally, right? Accordingly, the land acquisition problem also will increase, and that again will add into the cost of construction. So that's about cost of construction. Then about volume and nature of traffic. So if you have a heavy traffic or a high speed corridor where you will be having lot of trains moving around, it would be appropriate to use a broader gauge. Okay, so if you have a greater traffic, obviously uh, you will be opting to use a broader gauge than the smaller ones. Okay, then talking about development of area. Now if you want more goods to be transported from one place to the other place, obviously you need bigger vehicles. So to hold bigger vehicles, you need to have bigger or wider axles. So wider the axle, wider is the wagon width, bigger is the wagon that you can carry, and accordingly wider would be the gauge that is expected. So if you want to see development in a region by supplying the raw materials to the industries or by taking the finished goods to other distribution places in a faster pace or in greater quantity, you need bigger wagons with bigger axles, and this again demands for a wider gauge. So development is expected to be more if you have a broader gauge system. Then physical features of the country. So usage of narrow gauge is usually required in hilly areas where there is steep slope, sharp curves and improper gradients. Even in certain plain areas where the traffic is less, people normally don't spend much, and that's why even in flat areas you will be depending upon narrow gauge or light gauge. That's about physical features, right? Then speed of movement. Greater the speed that is required, broader will be the gauge to be provided. So it depends upon the wheel dia. So the speed is considered to be as the function of the diameter of the wheel, right? So the wheel dia required will be equal to 0.75 meters multiplied by the gauge of the railway track. So to maintain a high speed on a broad gauge, say 0.75 multiplied by 1.676 would give you what should be the diameter of the wheel to achieve the desired amount of speed, right, on the railway track. This is basically for stability. Okay, then uniformity of gauge. So when we talk about uh, all these important factors which influences the selection of the gauge, okay, it would be required for you to understand about the uniformity of gauge as well, right? There are different gauges as you are already aware of, and you have already understood about the various factors influencing selection of a gauge. Now it is required for you to understand about the uniformity of gauge. Now uniformity of gauge means uh, in some places you will be having narrow gauge, say for example, or in some places you will be having railway tracks which comes under or which falls under meter gauge, and then all of a sudden you have a very high traffic corridor where you have broad gauge provided. So all these variation in the gauges leads to discontinuity of travel, because the vehicles which are meant to travel on a broad gauge cannot be operated on a meter gauge or narrow gauge, because their physical dimension itself will be different, right? The the wheel size, the axle size, and the speed that can be achieved. All these mechanical specifications will change from vehicle to vehicle depending upon the gauge. So, gauge in a country is expected to be uniform throughout as far as possible. It might not be possible to the 100% extent, but it should be as less as possible. The variation should be as less as possible, right? This is because when you have variation in the gauge and the vehicles are restricted to move only to certain distance because of the change in gauge, people who are traveling in such trains will face lot of uncomfortability in shifting goods from one train to the other train, or shifting their luggage, catching the seats once again, and accommodating themselves. So all these comfort level issues starts coming up, or it starts popping up, right? So to avoid these kind of problems, apart from these, there'll be theft, and there'll be damage of the goods. You might be in the mid of your sleep during your travel, and all of a sudden you are made to get down from the train and hop into the next train. I don't think it would be comfortable for the passengers, right? So to avoid these kind of issues, you need to have a uniform gauge system. So uniformity of gauge again will lead to lot of advantages, like it will reduce the delay and cost and hardship. It will also avoid the complications during transshipping, difficulty in loading and unloading of the goods, labors and people might also be reduced. Possibility of theft or misplacement of your goods again might be reduced. Large shed required to store the goods. If you have certain delay in the next train wherein you need to shift, right, you might need a larger space to keep all the goods safely. So that requirement of duplicated sheds will be avoided. Then you will have to depend upon labors, and if the labors are not there in the place at the required time, then obviously you will have to do it by yourself, which is again impractical, right? Then there is something related to wagons and number of wagons required. Suppose if you are traveling in a smaller vehicle, and if you want to shift in a larger vehicle, obviously you will be having plenty of space, right? But if you are moving from a larger vehicle to a smaller vehicle, the number of wagons required, wagons are bogies, what we call in our local language. Okay, those are not called as bogies, but technically they are called as wagons. So the number of wagons required will be more when you are shifting from a bigger vehicle to the smaller vehicle. So this thing can be avoided. And then also duplication of the platform might be reduced. And during military emergencies or emergencies like natural calamities, you might not want to get into such issues. That's why it will not be so comfortable for you, right? So changing from one gauge to the other gauge is quite expensive, which will again add to the cost. And then the passengers will have to bear all these different costs, and that's how the popularity might come down, and people might get discouraged in using these kind of mass transport systems. So these are some of the important uh, explanation on having a uniform gauge system. So I suppose you have understood quite well about what a gauge is, what different types of gauges we have, right? Wheel gauge and then track gauge, and what are the gauge dimensions that we use in India, what are the gauges that are used elsewhere, right? And the importance of having a uniform gauge system. Upon understanding all these, we should next move towards the components of discussion on components of a permanent way. Now I'll start my discussion starting right from the top of the typical cross section, what was discussed in the first video. Um, so, in the typical cross section of a permanent way, the first component that comes is a ray. So this is what we will be starting our study with. So from top to bottom, we shall discuss about each of these components in detail. Right. So talking about rails. So rails are actually the longitudinal members which are meant to carry the vehicle, or it behaves like a path for the vehicle which is traveling upon it. So the vehicle that we have here are trains. So trains have two components. One is the locomotive, and there will be trailing wagons. Okay, one is motorized, whereas all the other ones are non-motorized units. Okay, so you have locomotive, which people call as engine, right? So the locomotive has an engine into it, which is a mechanical component, which initiates the kinetic energy in the vehicle. Okay, so the locomotive is the one that propels the whole train, which has an engine in it, and it will be pulling number of wagons behind it, or the trailing wagons behind it, right? All these units will be resting ultimately upon the path, that is the permanent way, and the surface where these vehicles come in contact first with the permanent way is the rail. So the function of the rail is to provide a hard, smooth and unchanging surface for passage of heavy moving loads with minimum friction between the steel wheels and that of the steel rails, right? So these rails, they are actually responsible to provide a hard, smooth and unchanging surface. They are also responsible to carry heavy loads, shocks, vibrations and lot of lateral and vertical forces given by the vehicle moving on them. And the rails, they show minimum wear, and hence they reduce the repair and replacement costs. Rails also they help in transmitting the wheel loads into the sleeper, and then through the sleeper to the ballast cushion, from the ballast to the formation, and then from the formation to the earth below. Okay, so these are some of the important functions of rails. Now, these rails, though they might look very simple to us, they have a very complicated uh, composition within them, chemical composition within them, right? And the standards are very specific. Even a slight variation in the chemical composition during the manufacturing process will lead to lot of complications in terms of failures and distresses in the rails when they are used at the site. So to avoid those complications, the standards are being prescribed about which mineral or which component has to be provided in what percentage to manufacture a rail. I think you are already aware that there are very few industries, and most of these industries are government owned and government operated, where the rails and wheels are manufactured. It is still not been privatized. Okay, so for ordinary rail, basically you will be having carbon, manganese, silicon, sulfur and phosphorus into the system. So for ordinary rails, for a nominal usage, the carbon is expected to be around 0.55 to 0.68%, manganese between 0.65 to 0.90%, silicon between 0.05 to 0.3%, sulfur between 0.05 and less, and phosphorus should be less than point or 0.06% and less. Okay, so this is how the ordinary rails are expected to be chemical. Now when you are trying to use these rails in places like points and crossings where the rails will be crisscrossing each other, especially in railway stations. You might have seen there will be a lot of wear and tear that will be taking place, and hence you expect the rails to be much strong and hard, right? That is why you can you can expect the change in the composition to be seen. So you can observe that the manganese percentage will be increased. The carbon content should range between zero point 0.5 to 0.6%, manganese between 0.95 to 1.25%, silicon between 0.05 to 0.2%, and then sulfur between sulfur point zero 0.06 or less, and then phosphorus 0.06 or less. So you can see the difference here prominently between the manganese used in percentage of manganese used in ordinary rails as well as in that of the points and crossing. So this is about the typical composition of rails that are expected. So the remaining things I'll continue in the next video.